All right. Well, good morning, everybody. Welcome to the latest installment of the Bureau Seminar Series. Happy New Year. All right. Hope everybody's staying warm. Just a few quick reminders. So again, we have QR codes in some of the hallways and whatnot for speaker suggestions if anyone's interested in that. As always, we'll have questions till the end and we'll moderate those both in person and online. Without any further ado, I'm going to introduce, I'm thrilled to have Becky here today talking about the Bureau work out at Balmorhea. I've got quite a comprehensive bio here, so stick with me here. It's fun. So, experienced. So, Ms. Smith is a native of Dallas, but spent many summers with cousins in Richmond, Virginia. She earned an undergraduate degree in geology from Virginia Tech, then worked at core laboratories before moving to Austin, where she worked for the U.S. Geological Survey, Water Resources Division, and PEG while studying chemistry at UT Austin. But she decided that chemistry was not for her. So she and husband Steve, also a geologist, sold most of their belongings, flew to Germany, where they purchased a used VW van and camped out on the edges of many major cities in Europe. They drove up the west coast of Norway, north of the Arctic Circle, then made their way back down through the USSR and Eastern Bloc countries before popping back out of Austria, which was no easy feat. Then they drove south through Yugoslavia and Greece, but it was cold, so on to Israel to make money as migrant farm laborers, eventually making it back to Europe, then England, before flying home to very concerned parents. This was, right? This was before the internet or cell phones, after all, right? Upon returning to Austin 18 months later with the van, Ms. Smythe briefly came back to work at BEG, then skipped over to a groundwater consulting firm, continuing to work while earning a master's degree at UT Austin in geology, hydrogeology. Thank you, Jack Sharp. 2 years later, Ms. Smith had the opportunity to come back to work at BEG once again. Since 1997, she has worked with the hydrogeology, then coastal studies groups, where she was part of the original airborne LIDAR team, then with CO2, and now back to hydrogeology. So join me in welcoming Becky for this talk. Thank you very much.
Thank you. Is this on? Okay. Show light. Happy New Year, everyone. Thanks for showing up. I'm just going to jump right in here. So I'm using the word continuing in the title here because this is a long-term study. We originally started in 2018 working on this with Brad Wolliver as our project PI, but things changed, and now JP Nicot is our project PI. I've got a lot of people to recognize here, and these aren't even all of them. I'll show an acknowledgement slide at the end mentioning others, but just wanted to emphasize that this is definitely a group effort. So, why do we care about recharge to this Balmorhea-area springs? And it's because it's a group of springs, and it forms an oasis in the desert, and Springflow is declining. So I'm going to talk about a lot of different things today, starting with regional hydrogeologic setting and highlights of earlier work by others going back as early as the 1930s. I'll give a brief excerpt of more recent work that BEG focused on, mainly JP's work, between writing up the results between data collection that we undertook between 2018 and 2022. Most of the data I'll show you is from this period of 2022 to the present, where we've been focusing more on physical hydrogeology and interpretations, show a few interpretations based on some preliminary data processing. And then I'll just very briefly mention where we're going from here. So the objective on previous studies and current studies is how to preserve spring flow given natural and man-made groundwater demands, that is lack of rainfall and long-term production of what we are calling fresh water here, fresh groundwater. One of the landowners said to me recently, it's like, you know, sometimes we have to chew our water out here before we can swallow. So it's definitely fresh is a relative term. Anyway, so the results to date, which are not just from BEG, but other workers too, are that we've got a good conceptual model for the spring recharge pathways or the capture area. We have a good understanding of the chemical indicators for sources of spring water, but there is still some spatial refinement needed. And that's where the protection of the springs comes in, is if we can identify exactly more precisely what the pathways are, maybe we can keep some of the large scale production away from those areas. Not that we can keep it away, but we could just make recommendations. We have a broad understanding of the physical hydrogeology, but we definitely need more data in certain areas. And I'll show you maps for that. Then we have a lot of significant previous work. I already mentioned USGS, but Jack Sharp and a bunch of his students over a 20-year period have contributed greatly to the understanding of the spring system. I wanted to point out here that one of our limitations is lack of rainfall. And during this study period, we've only seen one major rainfall event, and that was in the fall of 2022. Want to point out an existing, here are links for an existing contract report and published paper. Thank you, JP. Okay, where is Balmorhea? It's northern Trans-Pecos, Texas, which is Trans-Pecos is everything to the west of the Pecos River. Here's the town of Balmorhea. We're west of Fort Stockton, east of Van Horn. Here are the Apache Mountains. We're at the northern edge of the Davis Mountains, kind of south and east of the Salt Basin right here. And shown in this outline here, this dashed line is the Capitan Reef rocks, and they're also defined as a major aquifer, the Capitan Reef. I want to point out that I've got a star here at the intersection of three counties, Culberson, Reeves, and Jeff Davis. So a lot of my maps are at different scales, so I've tried to include this star at the intersection of the three counties on most of the maps to help you orient yourselves. As I mentioned, there is a spring source conceptual model. First, I'll show you, here's our star at the intersection of the three counties. We have an idealized future study area in the blue outline, but as you can see from the red squares and dots, we don't have data collection points over very much of that area. We've got some big gaps out in the west. I am making good progress in contacting landowners and getting access to some properties in these gap areas, mostly like a little bit north of the Apaches and southeast of the Apaches, and also to the northwest of Balmorhea. So there's hope. There's hope for filling in those gaps. So the two pathways for groundwater to reach the Balmorhea Springs, these little these blue stars are a little bit hard to see, but there's the Balmorhea State Park right there, that middle spring. Like I said, it's a spring system. The two pathways for groundwater to reach the spring area have been hypothesized to come from the Salt Basin, both from a more northerly path and also from due west. And also there's some evidence of water flowing up the Salt Basin this way and then hitting major structural features and zooming off to the east. And then there's also, we call that the baseflow. There's also what we call the local storm flow, which is water that comes directly out of the Davis Mountains. So again, our question is, can industrial scale production locations be, can we place those large production wells for fresh water, especially on the southern edge of the Delaware Basin, in a place that will have less impact to the spring flow? This is a hydrogeologically complex area. Water Development Board has defined major and minor aquifers. In this area, we have two major aquifers, the Edwards Trinity Plateau. Oh, well, here's our star. And we have the Pecos Valley Aquifer. Minor aquifers, there are 4 of those that overlap in the study area. Igneous up here in the Davis Mountains, Capitan Reef Complex, which is a little bit difficult to see here. It's coming down right there, and Rustler. And we also have the West Texas Bolsones, which overlie the Salt Basin. So let me just briefly talk about some of the geochemistry work that JP has done. We have over here on the left is a map, and I couldn't put the star here because there's just too much there, but there's the intersection of the 3 counties right there. Some of the physiographic features we have are Toyahvale Basin, Davis Mountains down here. A major structural feature, which complicates and probably controls a lot of the base flow, a regional groundwater flow, is the Stocks Fault. It's not cooperating very well. The Stocks Fault coming along here. Here's Balmorhea right there. So in summary, we have 3 different types of water that have been defined. With the help, you can see those with the help of this Piper plot, where we have, this is a trilinear diagram of anions, chloride, sulfate, here's high sulfate, and bicarbonate, high bicarbonate. Over here, we've got cations, increasing calcium, increasing magnesium, increasing sodium plus potassium. So we've got the Rustler water up here, which is really high sulfate water. It's pretty high TDS also. Got the igneous water, which is high bicarbonate and really low TDS, or total dissolved solids. So very fresh water, almost slightly saline water from the Rustler, but people drink the Rustler water up there. And then here we have the excuse me, we have the springs, the spring type water. You can also see, based on those color coding, how those are sort of banded, and it makes sense that the Davis Mountains water is coming out of the Davis Mountains, or the igneous water is coming out of the Davis Mountains, which are mostly rhyolite. And then we have the Balmorhea type water, this yellow, actually occurs in a valley on the front side of the Davis Mountains. And some of that water is the high TDS, but in a lot of cases on the front side of the Davis Mountains, we see very fresh water. Just one more thing about the chemistry is that a lot of people there have been hypotheses in the past that the high TDS nature of the Balmorhea Springs water, which we see is around 3,000 milligrams per liter total dissolved solids. A lot of people have hypothesized that that's from upwelling of deep brines. Now, we are on the edge of the Delaware Basin. Or even, well, not from oil field activity, but just natural upwelling. And JP did a good job of showing that the high TDS water is really from dissolution of halite, which, supports the migration of water from the west to the Salt Basin. We see in the pool water at the Balmorhea State Park, we see occasional influxes of fresh water, so freshwater pulses, and the pool water actually decreases from 3,000 down to about 1,000 milligrams per liter TDS briefly after major rainfall events in the mountains. So hence this influx of storm flow. So this is just a summary about, tying the water chemistry and water flow to the geologies. I think the geochemistry of the base flow, the higher TDS water in Balmorhea Springs, is mostly controlled by groundwater flow through Permian rocks. Okay, and interaction with a lot of the evaporites in those rocks. However, the subsurface pathways of the base flow that the base flow is thought to follow, and these episodic influxes of storm flow are really controlled by Neogene geologic history. So I thought that was interesting. But so let me talk about the more recent geologic history. Here we've got, here's the town of Balmorhea right there. This dark shaded area is the quote Trans-Pecos volcanic field. Lot of high silica volcanics and intrusive rocks in that area. Trans-Pecos volcanic field, age about between 40 and 25 million years. And that that influences the chemistry of these igneous rocks greatly influence the chemistry of what we're seeing as the storm flow in the Balmorhea State Park pool. Up here we have the Salt Basin, and which is more recent. We started having tensional forces in western US, definitely West Texas, around between about 20 million years in the present, where we started seeing basin and range rift faulting. So that, as I mentioned before, I pointed out the Stocks fault, and that does have some control, as we've found, on the flow of water, of this base flow water towards Balmorhea Springs. Quickly, just want to show you this map of data locations. Here's our star with the 3 counties. Here we have the Apache Mountains, the Davis Mountains. I just wanted to show you the distribution of the data points we have for measuring for water level data in our study. And these are a combination of BEG and Texas Water Development Board data, mostly from wells. The background is color-coded by, we've sort of generalized the geology. So everything in blue is Permian, both Capitan, Rustler, Castile, and Cretaceous rocks are there, igneous, Bolsone, and Pecos Valley. So what I did with these data is I constructed a potentiometric surface map, really breaking all the rules for doing that sort of thing, because, when you make a potentiometric surface map, you want all of your wells to be completed in the same geologic unit. We've got 5 here. You want all the measurements to be fairly close in time, and I had to go out to 10 years to get enough data to contour anything. I did not include any of the faults, and there are very few data points for several of these contours, especially the Permian units. So these are the only wells that we had data from for wells that were completed in Permian. But still, the directions of groundwater flow that you can see by going, so we're going from high potential or high head here, 6,000 feet down 5,000, 4,000 in the Davis Mountains. These directions of groundwater flow are consistent with the conceptual model, even using this approach. You can also see that there's evidence that we've got flow out of the Davis Mountains and coming up in this southern Bolsone area. We've got, we've got indications of flow coming away from the Salt Basin, not directly towards the springs, but at least in the right direction. So that was encouraging to see this. We've got, one of the goals is to be able to do an area-wide water level measurement campaign and improve this sort of approach to potential metric surface. I'm going to zoom in here. This map down here is the same area as we just saw on the previous map. Here I'm showing I've superimposed watersheds on the map just to orient you. Here's Balmorhea right there. These dots are the 3 spring areas. And then going up here, what I wanted to show you is that we've got monitoring locations in distinct watersheds coming from the high Davis Mountains down towards the flats, towards Balmorhea. Mount Locke is the location of McDonald Observatory. It's right up in that area. So you can see we are going from high elevation to low down these watersheds. These are the watersheds monitored to date. So again, well, a different question is with regard to the local storm flow is, can we track water pulses coming down these watersheds after heavy rains in the Davis Mountains, and then see correlative freshening of water in the pool? So the answer is yes, and I'll show you some of those data. This is just a summary of our logger responses. I've got the watersheds listed here with both wells and surface water monitoring points, and the X's are logger responses. So that means a logger response is when we see a significant increase in pressure or change in TDS after heavy rainfall. You can see there's not a lot of X's on here, except during the fall of 2022, where we had a concentration of responses in loggers, and we saw freshening in the pool. Just a little bit about the loggers I'm talking about. We have 3 types of monitoring sites: springs, creeks, and water wells. We have 3 different types of loggers. One that measures pressure, temperature, and and conductivity. I'll be referring to, in some of the plots, I'll show units of microsiemens per centimeter, which is a proxy for total dissolved solids. We have rugged trolls, which measure pressure and temperature. We more commonly put those stream beds. And then we have barrow trolls at both high and low elevations, because our loggers are not vented, so we have to correct. We get pressure readings and we have to convert those to height of water above loggers. So that's why we need the barrow trolls also. Here's an example of a freshening event, looking at logger data from of loggers that are in the Balmorhea State Park pool. We have depth, which is really height of water over the logger. We have conductivity and temperature. So during the first part of this study, we thought, and plotted against time. This is from June of 2018 to June of 2023. During the main part of the study, we thought this was our event. This was our major freshening event that we saw during the first main part of the study period. And thankfully, we've been able to keep loggers in all these locations so that we were able to catch this one in the fall of 2022, where we saw, we have this base flow going along here a little over, around 3,000 milligrams per liter TDS, close to it, and then dropping down after this major rainfall event down to, around 1,000. Same time, we saw a big drop in temperature. So again, these are our documenting the the base flow and the storm flow. One of the things to notice is that most of the rainfall, which is depicted by these blue lines coming down from the top, here's a scale over here for rainfall. Most of our rainfall events happen in the fall, and this is kind of interesting. This area used to experience major rainfall events on a monsoonal cycle, like between June and September. Now we're seeing just, occasionally the only heavy rainfall we've seen has been more in September and October. So there are changes taking place. Another thing to point out is that on this plot, I'm only showing rainfall over the Balmorhea State Park pool. But we have rainfall data from other locations too. So I mentioned that, well, you may have seen on this slide right here that at one point our loggers were stolen from the bottom of the pool. Had to take divers to do that. So somebody was really determined. And I just happened to be out there, and a landowner called me, and he was at the park swimming with his family and said, you might want to get over here. I think one of your loggers is just sitting on the side of the pool and the other one was gone. But so anyway, but we were able to get them put back in. We were able to replace them with new loggers. And here I'm just zooming in so you can see a little bit better this fall 2022 event. And the interesting thing is here is that we've got the rainfall over Balmorhea, but we didn't really see a response in changing water level in the pool until after a subsequent rainfall event. So that's something to look at a little bit more here. Another location, Phantom Spring, which is nearby. I'm just showing the full data set here. We've always got problems with these loggers. They stop working, et cetera. We have to replace them, and then we have different levels after we replace them. But if we zoom in on this fall of 2022 event, we can see we were able to capture a huge increase in water level over this logger, about 5 feet in less than 24 hours. So not a place you would want to be when this was happening. Here's just some photos of Tyson McKinney installing our logger in the cave. And I understand that this logger right now is no longer underwater. It's gone. So I'm going to just show you some examples of data from creek sites, just photos of what these look like. I think Marcus Gary, who's here, invented this pipe bomb housing for rugged trolls. And so what we do is we bolt this housing to the bedrock and then slip a logger in it and go back later and grab it, download it. So just this is a location where I'll show you. So here we have, this is the edge of the Davis Mountains, the northeastern front of the Davis Mountains. I'll show you an example of data from this Madera lower stream location. It's a pretty steep setting. But one of the things I want to mention here is I'm going to show you evidence of pulses of water coming down out of the mountains. And then we see, really soon afterwards, we see freshening events in the springs. And, we're not saying that the water that's coming down out of the mountains is what's actually showing up in the springs, but with, like most fluids, this water coming down out of here is pushing water that's in this valley down towards the springs. But, there are some strong correlations with timing. I guess I should mention, again, we've simplified the geology. So here's the background. This is a sort of a flat plain here that's underlain by Cretaceous rocks. And the water in the Cretaceous aquifers is generally much higher TDS, but just so happens that the wells where we've been able to sample water in this area have all very fresh water, which, you know, supports the idea of water coming down out of the mountains, surface water flowing down out of the mountains, seeping into these fractures, and then flowing up towards the springs. So one example of data from a creek logger. So we have stage, height of water over the logger. Again, this is a pretty long time period. One thing to point out, as I mentioned, that we have to correct the convert from pressure to height of water. And this is just to point out how important it is to get our pressure corrections right. So here we have a dry creek bed, and we're showing almost like a half a meter of water over it. So we have been able to correct that by interpolating between the two pressure loggers. I really like the fact that you can see when the creek bed is dry, we have huge temperature fluctuations. After major rainfall, you can see here, this rainfall, the water ponds in the creek bed and the temperature fluctuations are dampened. So I just think that's a really neat plot. Probably my favorite, but anyway, again, we see this larger event in the fall of 2022, where we see freshening of water in the spring. We didn't really, in the spring pool, we didn't really see freshening events correlated with some of these earlier ones. Here's another plot from the same location where we've corrected the pressure. So when the creek's dry, we're right at about 0. I've added data from other rainfall locations, and this is zooming into the fall 2022 event. And you can see definitely you can see the spatial correlation between the temporal between the rainfall events and the increases and then these pulses of water. Just mentioned we've got 5 different locations of rainfall data. Next, I'm going to jump next to wells, where we have loggers hanging in water wells. We have different types of settings, some located right next to creeks and some located away from creeks. Show you next example from a set of wells that are down here in this little flatland in front of the Davis Mountains. Again, so we have 2 wells here. We have a shallow well that's only about 20 feet deep right next to the creek bed right here. And then farther away, we have a deep well. So here's the plot from the shallow well using the aquatrol data. Using the ruggedtrol data, which is why we only have pressure and temperature. Just wanted to point out that this is the only response we've seen in this logger since 2018. One time, a response. But the good news is we saw a response in the deep well right next to it, which could be just this water from the creek coming out to the side, or there could also be regional water flowing through here. We've still got a lot of data processing to do with looking at these changes in water levels in this deep well and seeing what that tells us about the properties of the hydraulic properties of the water-bearing units. In summary, we've got these 2 pathways for groundwater recharge, the regional pathway and also the local pathway. I mentioned that I've got okay, so first of all, these are only locations of loggers. We're going to continue on looking at both, mainly focusing on the physical hydrogeology, but the Reeves County Groundwater Conservation District, which wants to give us more money, is also very interested in water quality. They want to they want to know what the background conditions are of groundwater in their county, so that they might be able to document if there are any impacts from oil and gas activity. So it's just so they are very interested in water quality also, which is a good thing. Because, data are data. If we do samples for Reeves County, for their contamination concerns, we can also, add a couple of analytes and also keep adding data to our chemical database, and also have an opportunity to measure water levels in wells out in this region, and not just be restricted to the Davis Mountains local area. So I said I had an acknowledgement slide. I couldn't do this work without the landowners. Early parts of the study were funded by Apache Corporation. Since the end of 2020, we've been just sort of limping along, but keeping the monitoring network going. But it does look like we are going to have opportunities to get back out there and do more field work. In fact, I'll be there the end of this month, and then again in February. I've got 2 field trips where I'm going to be meeting landowners, showing them the loggers, looking at their wells, seeing if they'll let us start monitoring. So also want to thank my free scuba divers. Marcus is one of those. And that's it. Do you have any questions?
Thank you. That was awesome. Well, as always, you've got plenty of time for Q&A. I'll bring you the mics so the people online can hear you. And I see the people around this room, so I know we've got some questions. Just see who wants to be first. All right, there it is.
Thanks, Vicky. It's a really good review. Under curiosity, Marcus and I were talking, look at that control system. There's that. The model, the model. Take a certain amount. That was what mostly. Anybody.
Not that I know of. The problem is access to wells completed in those deep units. I was going to go back to a map here. Just yeah, here we go. Oops. Yeah. Okay. Yeah, so you're talking about this water here coming up this way east of Van Horn. Okay, so right now, are you talking about the early of the GAM models? Okay, so I think my problem is the lack of data. I mean, so we haven't had data to ground truth any of these ideas about, where the water is coming from. So that's the whole point. And, JP is really interested in working on a new model, an updated model for this whole area, but we just don't have the data yet. So that's why we're probably going to take several more years to keep trying to get access to private properties and access to wells. I'm not even familiar enough right now to tell you how deep the permit is in this area. Except for the Capitan does come down through here, and that is one of the units. So I guess it's going to have to be a combination of physical hydrogeology, where we access wells completed in units, and more chemical sampling. I've got access to a well right up in a couple of wells up in here that are completed in the Castile formation, which is permanent. And you'd think I might be able to get on this property right here. I just need to follow up on that university lands. So that would be that's pretty close to the area you're talking about, except it's kind of on the western side of the Salt Basin.
I was just going to say, if the permit got up here, those kind of basis is zero. It's got to be true.
There's got to be flow, and well, and we can't ignore the structure, the major structures. Just all the water is probably through there. Other questions? Thank you. Oh, yeah. Yep. Well, I just happened to, I think Brian Hunt has contracted with Pat Goodson to, we're going to be drilling some wells out in southwestern Travis County next week. And I'm hoping to be able to chat with Pat about that thing. Because you know he's had to sign all kinds of non-disclosure agreements. Thank you. Yeah, I've asked him about it before and he was very quiet. But I thought maybe if we're like out away from everybody, maybe he'll talk to me. Well, you know, that's a good question. Let's, you know, we can look at this plot of the where we saw the you know, this pulse of water coming through San Solomon. I'm sorry, coming through Phantom. At the same time that we saw the freshening event in the San Solomon Springs, which is the name of this spring system at the bottom of the Balmorhea State Park pool. And you know what I don't know is, you know, is this water, is this pulse here, is this part of the regional flow path or is it part of the local flow path? And so that's a big question. True, yes. And I probably read that about, you know, 4 years ago. So maybe somebody could help me out here. but yes, he did dye tracing where he saw, see if I could go back to one of these maps. He saw, so, okay, so here is, so here's essentially this Phantom. Here's Balmorhea State Park with another, there's another spring just across the road from Balmorhea State Park, Giffen Spring. And in his studies, he saw that there was connection between Phantom and San Solomon, but not Phantom and Giffen, right? You know, I guess I'm looking at a bigger picture rather than, you know, there a lot of people have worked on what are the differences between all these springs in this area. And JP covered that a lot in the contract report and the paper. But I haven't been paying that much attention to that. I've been looking more at the bigger pictures, like how can we document flow along the regional flow path versus the local flow path. So.
Anyone else? Question?
That'd be a great job. It's such a huge area. And have some data. Just wondering, there were a couple of times when we showed rainfall events that there was not freshening, and I know that lack of data attention. Do you have any hypothesis about?
Well, I think probably just say for given an example of the water coming out of the Davis Mountains, where we did not see a freshening event in the pool, you know, soon afterwards, there probably just was not enough rainfall to push water through the system towards the pool. So it was only this one time where we've seen in the fall of 22 where we actually saw a freshening event. And again, still like, you know, teasing out what, well, we know it's a freshening event. So we know it's water coming out of either the Davis Mountains or I did not even discuss the Rustler Hills, which are to the west of the springs. You know, there have been people, Water Development Board worked on that and, you know, showed that there was water coming out of the Rustler Hills, but I'm sort of talking in circles here now because that would be higher TDS water. So I guess it's just lack of rainfall. So our objective here is to have as good of a monitoring network as possible in place for in case it ever does rain up here again.
I want to ask you too, did it rain some?
Very little rain, no monsoonal season this year out there. And in fact, I mentioned that I just heard from one of my landowners that there's no water over our logger in Phantom Cave. And we've always had water over that logger since 2018. There's none now. So it's bad. I was showing you, I had this picture here of this drone shot. This is from October. We actually did get a little bit of rain since then. Oh, well, actually, this was October of 2023, which is some of the worst landscape I've ever seen out here. Here are just little remnants of these natural grasses. And this is an area a little bit west of McDonald Observatory. And most of the times I've been out there, this whole area is covered by these nice grasses. So there's dire conditions.
I have a question. Like that. I may access to those. How much
I'm not going to try to guess what the rainfall is going to do.
No,
Is that what you're asking?
No,
Or
I'm saying-
how? Yeah. Well, oh, okay.
So how big of a street is just waiting on?
It's a huge constraint waiting on rain, but maybe what I should address is, you know, how much of this decrease in spring flow is from lack of rainfall versus production of groundwater? Is that what you're asking? And you know, I don't know. I mean, there are many things we could look at, but we have to have data. We have to have monitoring data over long-term periods when it's raining.
Are you just kind of to the west and southwest? Are those white spots or are there other districts covering those counties?
Jeff Davis County is to the south, and they essentially don't do any data collection in the northern part of the county. Everything they do is south of Fort Davis. I can go back to the map and show you that. And I don't know why that is. I'm going to, like I said, I'll be out there in January and February trying to access more wells, and I'm hoping to talk to them. To the west is Culberson County, and they do not have a groundwater conservation district in the on the eastern half of that county. Their groundwater conservation district only covers the western part of the county. However, let's see, where can I go here? Well, we can just do this one. I don't have the county boundaries here. However, it's about county boundaries about right here. So, excuse me. Here's the Apache Mountains. So, Culberson County goes out pretty far to the west here and covers an area like this. I have just, right before Christmas, made contacts with two different ranch owners that own property in this area. And, they said they're real willing to work with me. So we'll see.
Anyone else? Questions? Yes. Judy?
Thank you.
You talked a lot about the freshman events. I wanna just ask you about the baseline composition mainly. Yes, is it pretty consistent, do you think?
It is consistent. It is declining. Like, I think, we have records going back from, since the 1930s where we were showing about, 60 million gallons per day discharging from the springs. We're down, it is a consistent flow now, but it's more, it ranges between 20 and 30 gallons per day. And the composition is steady, yeah. And,
So it's-
yes, yeah. And there, other people have done work, looking at the chemistry. JP covers that a lot in the contract report in the paper that I put links up for. So yeah, the composition has remained, pretty steady. And so and it also, other people have done work looking at the age of that water, and it's, you know, it might be, there may be some water in there that's coming out through the base flow that's as old as 2,000 years. So it's a long-term, well-established flow system. What we really need help with is the structure, the shallow subsurface structure. You know, when this project was started, we were promised the ability to look at some seismic data, but somehow that never happened. So I know that's not really answering your question, but because you're interested in structural geology, I wanted to mention that, you know, any help we could get would be nice. I also understand that the Scissor project might have some access to some seismic data. I don't know how shallow it covers, you know, so that's, you know, and how shallow do we need? You know, not really sure about that either. Welcome.
Do you think a general indication of percent production also?
Oh, the related to the oil and gas. Yes, that's a good question, Charlotte. Thank you. So, where are we here? Oh, we're here. Okay, let me zoom back out here. To this. This one right here at the beginning would be a good place. As I mentioned, the southern edge of the Delaware Basin, you know, comes through about like right through here, right? Something like that. And Apache for a while was operating the Alpine High, which is a play that's, you know, something like this. So there are, I don't have a map. I do have locations in those production wells. I just don't have it on here, these figures. But there are differences in, some differences in the chemistry of some of those wells, and also some differences in the pressure. Some of them are, we think, tapping Cretaceous units, and they're flowing at the surface. Others are not. Right now, there's not as much activity in the Alpine High right now, but really all of Reeves County is just incredibly active. Water production, brine injection of co-produced brine. I will say something very positive about Apache is that when they first moved into the Alpine High, again, I have a map of that, but I'm just not showing it. When they first moved into the Alpine High, they were actively protesting any brine injection well permits that might somehow impact the quality of water flowing to the springs along this baseflow path. But they are pretty much out of the Alpine High now. I really haven't kept up with who's operating there now. I know others have moved in that area. You know, they're producing mostly gas from their fracking operations, not as much oil. Have I answered your question?
Cretaceous age rocks.
Oh, Cretaceous and Rustler and Permian. Yeah.
All produce.
Producing fresh water for rig supply and frack, or are you talking about oil and gas production wells?
Fresh.
Fresh water, yeah, fresh. Yeah.
So Rustler and.
Rustler,
Cretaceous would be-
Uh,
would be-
right. Now there is also, in this area up here in southeastern Culberson County, there are some people who are producing large amounts of water from the Capitan aquifer for water marketing purposes. So that's the Capitan, which is just a little bit lower down in the Permian, but that's a huge water production zone. And, you know, there are concerns with that too. But those are some of the people who say they're willing to talk to me about property, which I was shocked by.
Are those water collection, those exempt wells? Right, these exempts?
The water marketing exempt from,
I thought most of these, I have no idea. I thought we were saying water fresh, quote unquote, water production. Supported oil and gas production.
right,
So they're exempt from permitting requirements.
right, but there's no groundwater conservation districts,
that part of-
so there's no rules.
So it's just completely. Well, we're about out of time. Please join me in thanking Becky.
Thank you.